Good afternoon, everyone, and welcome along to this lunchtime session. Thanks very much for either delaying or missing your lunch to hear about this. What I want to talk about today is, obviously, when you're deploying containerized applications to Kubernetes clusters, there's a lot of security things to be done. There's lots of different areas to consider. But what I wanted to do with this short talk is focus on 10 quick ways where developers of applications can improve the security you get when you're running in containers on Kubernetes clusters. So, very quick about me. My background is information and IT security. I used to be a pen tester. I used to test a lot of containerized applications and a lot of Kubernetes clusters. These days, I am a security advocate, senior security advocate for Datadog, where I focus on containers, cloud native, and that kind of thing. A couple of things I do in the community. I help maintain the CIS benchmarks for Docker and Kubernetes. If you've not come across CIS benchmarks before, they are essentially vendor-neutral benchmarks that let you establish the security of any Kubernetes or Docker environment. Quite a useful one to look up for if you're looking for more information. I'm also a member of a thing called Kubernetes SIG Security, which is a group inside the Kubernetes project that focuses on security. Anyway, let's get on with the talk. So, one more thing before I go on. My colleagues will be very annoyed if I don't mention it. I work for Datadog. We are a SaaS observability and security platform. If you want more information about the product, that's not really me. Just talk to my colleagues who are down there at the booth. They'll be happy to help you out. So, when you are developing an application to be deployed to a Kubernetes cluster, there's really two places that as a developer you're likely to be able to modify the configuration to improve security. First one is you're probably writing Docker files, or you're writing something else that ends up working the same way as Docker files. So here you can do things like configure what application packages are installed. You can configure various things about how that container will run in any environment. And then when you come to deploy to Kubernetes, you will be using workload manifests or something again, like maybe Helm templates or something else, but it works roughly the same way. You'll be having some kind of YAML that gets applied to a cluster. And again, here, what you can do is you have an opportunity to change some of the defaults that Kubernetes gives you. And there are some good reasons to change those defaults, which I'll talk about as we go along. So first up, let's talk about improving container image security. The images essentially are where all containerized applications start, right? This is where your application code lives, where your dependencies live. Getting that right and making changes there as early in the development process as possible is going to help improve your security. So there's a couple of places you can choose to kind of like make those changes. First one is base images, right? At the top of any Docker file, you'll see a from line, and from specifies the image you're starting with. At the top of that tree, there will typically be some variant of an operating system. That could be Debian, Ubuntu, could be Alpine, it could be Red Hat. What I would say about this in terms of environments I've seen is a good approach is to try and pick one. Pick one distribution as much as possible. You won't be able to do it for all maybe the third-party images you use, but for your own images, because it's going to help you with two things. One is hardening, because you can apply your hardening steps once in the base. Like if you want to remove packages, you can do that in one base image. And the other one is the ongoing horror of vulnerability management. If you're getting lots and lots of things about, you've got so many CVEs in your images, it's helpful to have them all derived from one base distribution because that's one place to look at in terms of your security. So if you're using these kind of images, that's definitely an approach to make. There is another thing you can do, and this depends more on your application, which is using minimal images. So there are some special options in Docker that let you choose the specific minimal base images. The first one at the top there is called from scratch. And scratch essentially is an empty Docker file. No files at all. So if your application is able to run with no operating system files, no shared libraries, no time zone files, no TLS certificates, what you can do is you can say, I want to run from scratch. If an attacker gets access to a scratch container, they're not going to have much fun because there's literally nothing for them to run. Makes the attacker's life super difficult. But it does depend on your application being able to run in that way, so not suitable for every app. If that doesn't work, but you kind of like the idea of minimal distributions, then you can do static distroless. Distroless is a Google project, and again, what it does is it's very, very small. It has things like time zone files. So if your application expects to see time zone files in the Linux distribution, it will have those. It has the TLS certificates, so it has some basic file support there. A third, more modern option, this one's fairly recent, is a thing called Wolfie from a company called ChainGuard. What they're doing is they're creating minimal images for a variety of different platforms, and they're trying to get the CVE count and the packages down as low as is possible. They have one for JDK, for example. So you can use Wolfie as your base image, and that should hopefully give you fewer vulnerabilities to manage. It should give you a hardened environment out of the box. Unlike some images which tend to be kind of very large to support lots of different use cases, this one is designed for production. It's designed to be as small as possible. So that's another way you can do it, to actually try and use one of these minimal images. That does take more work. The next thing, and this is probably the canonical sin of Docker security, is every container runs as root by default. This is a choice the Docker team made because it makes usability great, because you don't have any file permissions problems. However, running as root is not a good idea from a security standpoint. It's not quite as bad as running as root on a virtual machine, because Docker does actually limit your access, what root can do in various ways. But if you are designing new applications and containerizing them, doing something like this, there are different ways to essentially make yourself not run as root. This is one of them, which essentially involves adding a user and a group inside the container image, setting the work directory to that user's home directory, and then changing the user account. Doing this means you won't run as root. If you think about your applications before, when they were on VMs maybe, or servers, they probably didn't run as root. They weren't running as the root user. So in containers, you need to do the same thing, because otherwise the default kicks in and you're running as root whether you like it or not. So those are some of the images, some of the options you have in Docker files. But let's talk about Kubernetes. So what Kubernetes does is it orchestrates container runtimes. And that could be Docker, it could be CRI-O, it could be Containerd. All of those have a similar set of default security options, which are not super hardened. Both Docker and Kubernetes, when they designed them, they took the approach of we want everyone's applications to work out of the box. We don't want them to have to tweak defaults. So that means they're not super hardened, they're not locked down. This ends up meaning that there's a variety of things you can change, and you should change, when you're actually running your application. The area of the manifest is called security context, and it lets you voluntarily change security defaults. When you're deploying to production, your ops team or security team might also mandate some of these settings, but setting these in your own manifests using security context lets you test those hardened settings before they hit production and before some deploy fails because it didn't match some requirement. So here's some of the ones you can change. First one, privileged false. Privileged essentially means turn off all the security. I was actually talking to the person who put this into the Docker product, and he wanted to call it insecure. He said I wanted to call it the insecure option, but wasn't allowed to. So it's called privileged in stealth, but it basically means insecure. It should almost never be used in containers. And you can, in the security context, just explicitly set it as false. Makes it nice and easy for code scanning and linting tools to say, okay, this container definitely isn't going to run as privileged. Great. Unless you need that, and you probably don't, there is no downside to setting this in every single manifest you use. It's an easy one, easy win. Next one, allow privilege escalation false. Confusingly, this has nothing to do with the previous setting at all. It's a case of very bad naming. What this is a Linux kernel feature which says that once any application running on a machine starts, don't let it get more privileges than what it started with. So if it starts as an ordinary user, don't let it sudo root. Even if it's got sudo rights, which say, no, this process cannot gain more privileges. Unless your application needs to do that, and most don't, this is a free and easy hardening setting. Won't harm your application, will potentially annoy an attacker. So it's an easy one to set. Next thing to do, you can specify in security context exactly what UID and GID you want to run as. This is useful if you're using shared volumes, so you're sharing volumes between multiple different containers. At this point, you can say, okay, I know what I need the files to be owned as, because I've specified my UID and GID here. You'd want that to line up with what you're setting in your Docker images as well, but again, just lets you have it set to a specific value. I think actually one of the reasons that containers all run as root because they get rid of all the file permissions problems. Right? If I run as root, I've got no file permissions problems. It's great. However, not great from a security standpoint. So worth looking into that one. This one is kind of interesting. Read-only root file systems true. So containers are ephemeral, right? We've all been taught that containers are ephemeral. In a Kubernetes cluster, your container can move from machine to machine every minute, depending on exactly what happens. So you're not storing any state in the container. So if there's no state stored in the container, you can just set the entire root file system to read-only. This will really annoy attackers, because the first thing you do when you compromise a container is you try and download your tools into the container. And if the file system is read-only, you can't. This will annoy attackers, which is good for people trying to secure clusters. If you do need something like a temp directory to be available, then what you can do is you can mount essentially an empty directory into one path and write your temp files there, and that'll be writable. And then it's discarded when the container moves or gets shut down. But this generally will make the attackers' lives harder. Next one. Docker made the choice that when they started their runtime, they were going to give every container certain parts of root's privileges. So these are what's called Linux capabilities. Every single container by default gets a set of capabilities. If you're not running as root, you don't need any capabilities, because these are all things that only root can do. Things like, for example, they give one net raw, which is needed for like packet sniffing and things like that. And that's available to every container by default. If you're not running as root, you've already done that setting of turning off root user, you can just happily say, drop all those capabilities. I don't need any of those. If you do find you need a specific one, you can first drop all and then add back the individual one you need. That way it gets rid of all the other capabilities and you, again, hardening your container down. And this one is another one which is kind of interesting. Docker added a thing. When they originally did the security work on Docker, they tried to come up with how are we going to design this thing. They identified a lot of Linux syscalls, so those low-level interfaces into the Linux kernel, and said these are potentially dangerous. And what they did was they added a seccomp filter to block them. So even if every other privilege would give you this, even if you're running as root, you try and make that syscall inside a Docker container, it will fail. And it's actually quite useful because it has blocked several privilege escalation attacks, having the seccomp filter. What is extra interesting if you're running in Kubernetes is Kubernetes turns it off. So Docker turns it on, Kubernetes disabled it. It has done since the start of the project, more or less. And you can go and read a very long GitHub issue if you want to know the kind of reasons why they did that. But typically, if you're testing your application in Docker and it's running okay in Docker, the seccomp filter is not going to cause you a problem in production. So you need to go back and set this to turn it back on, because Kubernetes will disable it. It's recently become possible for cluster operators to re-enable it at a node level, but that's only very recently. Most clusters will not have that enabled now, so you need to do it in the actual application manifest. And the last one to talk about is resources. So one of the things about containers is they are all processes running on Linux machines. It is possible for a rogue process to chew all of the resources on that machine. A good example from an attacker perspective is the most common attack on containerized systems in terms of on the internet is people dropping cryptocurrency miners into your application containers and then using every single bit of available resources in order to mine crypto. You probably don't want them doing that. What you can do here is you can initially you specify two things. One is what you request in terms of memory and CPU, and then the other one is limits. If the container tries to go above those limits, it won't be allowed to. Now, this is obviously a slightly more dangerous setting because if it tries to, on the memory one, if it tries to go above that memory limit, it will out of memory kill the container. So you need to be very confident it's not going to need more memory than that. With the CPU one, it's a bit more forgiving. It will just throttle it if it goes above the limit required. So it won't actually stop it. It'll just throttle the process down. But setting these, especially if you've got a cluster with a lot of different applications from different departments, you don't want one chewing all of the CPU and all the nodes because something happened to it. So that's one to look into as well. We're doing 2 minutes. Awesome. So a couple of resources, things that might be of use to you if you want to know more about this. First up, in terms of the two areas I kind of talked about today, in terms of the first one here, Docker have a good page. They actually go through a lot of the security options of the Docker engine. Their page is actually well worth reading. The other one is a thing called Kubernetes Pod Security Standards. That essentially lays out all of the different settings you can change in your security in your manifests, everything that would go into that security context settings, and they actually give them different levels of terms of how much, how hardened you might want to be. But there's lots of good information there. There are a lot of different settings. Couldn't cover them all. It would take a lot longer to cover all of those. So that's well worth a look as well. If you're interested in learning more about container security, this is something you want to know more about, some resources I would recommend. There are 2 O'Reilly books on this. One is Container Security by Liz Rice. That one's been around. It's still got a lot of good information in it. It's well worth if you want the detail. The other one is Hacking Kubernetes, which came out last year. This one takes a more attacker's eye view of the world and says, what can attackers do? How would they try and do it across supply chain and also Kubernetes as well? But again, it's a very interesting read. It's got a lot more detailed information. I'll mention Datadog's security labs because we have a series of posts running at the moment on what we call container security fundamentals. And that is going down into the low level of exactly how containers work on Linux machines and some of the things you can do. There's also a container security site, which is a site I own, which has more resources as well. And lastly, just before I finish up, because it's flashing at me and telling my time is up, I've got Kubernetes SIG security and CNCF tag security are two groups which meet regularly and talk about Kubernetes security and cloud native security. If you just want to come along and listen, you're more than free to do so. There are regular Zoom meetings that you can attend. Cool, and thanks very much for that. Hopefully that was useful. And if you have any more details, just get me on those. Ah.